Hello, everyone. Today's topic is rational expressions. Let's give a definition first. What is a rational expression? A quotient of two algebraic expressions is called a rational expression. For example, we can have a x over x squared plus 1, or square root of x over square root of x squared plus 1, or anything like this. So any quotient of two algebraic expressions. Okay, what is interesting about algebraic expressions? They can have a domain. Well, algebraic expressions have domain also, but rational expressions have tendency to have some points excluded from algebraic, from domain of expression, just because we are dividing, and we do remember that division by 0 is not allowed, right? For example, I'm going to, sorry, touched it in the wrong place. I'm going to talk a little bit about domain of the function 1 over x. So domain of the function or of expression 1 over x, let's say. So because we cannot divide by x, we cannot use x equals 0 here in possible values for this expression. If you draw it a number line is going to look like this. So you can use all possible x's except one, which is x equals 0. So number line is going to be shaded everywhere here and everywhere here except 0. In interval notation, it's going to look like this. X belongs to interval from negative, from negative infinity to 0, 0 not included, unified with interval from 0 to positive infinity. So that's a domain. Let's consider another example. Example 2. And we are going to have a square root of x divided over x minus 1. First, we are going to look at numerator. Numerator is going to have a restriction on domain because we cannot extract square roots of negative numbers. So first restriction is that x is greater or equal than 0, which comes actually from the square root, right? Expression under the square root is greater than 0. I'm going to put square root. Second restriction, we cannot have 0 in denominator, so x minus 1 cannot be equal to 0. These two restrictions are going to look at number line next way. So first we are going to label 0, and second, when x is not equal to -1 means that x is not equal to 1, right? X minus 1 not equal to 0 when x is not equal to 1. If you plug in 1 here, it's 1 minus 1 equals 0. So I'm going to also circle 1 here. Why do I draw empty circles? Well, first, I don't really know if the circle, that number itself is going to belong to domain or not. So I'm going to consider it separately. I'm going to start with my first x greater or equal than 0. I'm going to shade all possible numbers which satisfy this condition. And these are all numbers greater than 0. This is 0 and this is 1. Square root of 0 is equal to 0, so 0 itself is included. I'm going to make it a dark circle. Now, for my second condition, x is not equal to 1. Actually, it excludes only one point. X equals 1 from our domain. I'm going to, well, instead of erasing just one point, I kind of erased the whole thing. Okay, sorry, guys. I'm going to redraw my number line again. I don't understand why it actually likes to draw everything at this inclined way. Yeah, sorry. X excluded 1 and all the numbers. So how it will look in interval notation? In interval notation, we are going to write down x belongs to the interval from 0 to 1. 1 is not included because we cannot divide by 1, and also x can belong the interval from 1 to positive infinity. Okay, very good. Well, another example of finding domain. Example number 3. more complicated rational expression, x divided over x minus 1, and second parenthesis x minus 2. Here we have a product of two factors. Each one cannot be equal to 0, right? Which is going to exclude from x two different points. One is going to be 1, right? And another one is going to be 2. All other points are allowed over here. So I'm going to kind of draw shading and write down that x belongs the interval from negative infinity to 1, unity sign, from 1 to 2, unity sign, and from 2 to positive infinity. Okay. What else do we need to know about rational expressions? We'll need to know how to simplify rational expressions. And to simplify them, we'll need to know a simple rule. I'm going to write down simplifying rational expressions. So a simple rule we need to know is that when you have a rational expression which has two factors in numerator and two factors in denominator, and numerator and denominator factors are same, you can always represent it as a over b multiplied by c over c, like two fractions. And we know that if we take a number and divide it by itself, we are going to have 1. So this expression is 1. So normally, guys, in practice, we just call that we cancel c, but actually we separate it and kind of substitute with 1, right? But we are going to use the term of canceling, and you can always do it. I'm going to consider a couple of examples. Let me move it a little bit up. So example number one is going to be a rational expression x squared plus x divided over x minus 1. So how can we use this nice property in simplifying rational expression? Well, let's look at numerator. We remember that we can factor out the same factor from both terms. Here, same factor is x, right? There's two x's and there's one x here. So I'm going to take this one x outside of each term. For the first term, we are going to have leftover x. And for the second term, when we take out x, actually it's 1, which is going to be left, right? And in denominator, we have x minus 1. We see that x and x is repeated in numerator and denominator. It can be canceled. That's what I'm going to do. Well, again, we are not really canceling anything, but we are kind of separating a fraction, which is equal to 1, but we can always kind of cross them. And final expression is going to be x plus 1 over x minus 1. Okay. Something more complicated. Compound fractions also require simplifying. What are compound fractions? Well, compound fractions are fractions where you have fractions in numerator and denominator, so more complicated fractions. I'm going to show you an example. Example number 2. For example, fraction is x over y plus 1 divided over 1 minus y over x. You see that there is a fraction inside of the fraction. To simplify this expression, we are going to first bring numerator and denominator separately to common denominator. So simplify first fraction on numerator. So here common denominator is y because 1 does not have any denominator. So I have x plus y over y. So I kind of multiply 1 by y numerator and denominator. For denominator, common denominator is x. So I'm going to have x minus y divided over x. Now I'm going to use the rule that if we divide two fractions, we multiply actually the same fractions, but we flip this one. This one is going to be flipped to do this division, right? So instead of division, we are going to do multiplication with a flipped fraction. And that's going to be x minus y. And that's going to be our final answer. So x plus y You can put x after and x minus y and y after. Unfortunately, we cannot cancel anything here, but still we simplify the fraction. It looks like instead of two-story building, like one-story building now. Okay, what other operations we can do on rational expressions? Rationalizing denominator. You already know that we can rationalize denominators for numbers. Now we are going to look how to rationalize denominators for expressions. Sorry. For example, we have a fraction. I'm going to call it example number 3. We have a fraction which looks like this: y over 1 plus square root of x. Why this denominator is non-rational? Well, the reason is because we have a square root in denominator. Square root in denominator is non-rationalized denominator. What we are going to do, remember what we were doing with numbers. We were multiplying by a conjugate. With numbers, everything was kind of simple. It was a missing like power of the root. Here, conjugate of 1 plus square root of x is 1 minus square root of x. Why? We're going to see. Let's multiply by 1 minus square root of x, both numerator and denominator. Why do we need to do it on the top and on the bottom too? Because this way, we're just multiplying fraction by 1. If we do only denominator, we are changing the fraction. We are dividing it by something. Now, I'm going to copy numerator with parentheses, not changing it. For denominator, I'm going to use the formula. Use the formula a minus b multiplied by a plus b, special formulas, right? It's a square minus b square. My a here is 1, right? My b here is a square root of 2x. So 1 squared is just 1 minus, and square root of x also squared. Well, numerator is same. I'm just going to copy it. Sorry, put plus instead of minus accidentally. In denominator, we are going to have 1 minus x, because the square root of x squared is going to give us just x. Well, now we don't have anything irrational here. Well, guys, the only little feature over here is that when you square a square root of x, you should understand that x is supposed to be greater or equal than 0, just because you cannot extract the square root of negative x's. So then when you square it, it's still going to stay positive, okay? Otherwise, that's all. And now we are going to solve several problems on ourselves, and I'll ask you to stop my video, try to do the problems on your own, and then start it whenever you are ready. I'm going to start solving the problems maybe like 5 seconds after I write them down, but I suggest you to try solving the problems without my help first, okay? So self-solving, self-work. Problem 1. Find domain. And the fraction is square root of x minus 1 over x. Oh, sorry, switched the controls, I guess. X plus 3. Number 2, simplify. And that's going to be expression 2x plus 2 divided over x squared minus 1. Number 3, another expression to simplify, x over x plus 1 squared plus 2 over x squared minus 1. Here we need to bring it to common denominator and kind of add these two fractions. Maybe something nicer is going to come out. Number 4, sorry. Number 4, complex fraction, also we'll need to simplify it. X plus y over x divided over y plus x over y. So simplify. And the last question to simplify is going to be a rationalized denominator. Maybe I should write down the rationalized denominator first. Otherwise, it's going to be not clear what to do. So here we have 2x minus y divided over square root of x minus square root of y. So what I'm going to do, guys, I'm going to count to 3 and start solving the problems. I suggest you to try first the problems on your own, okay? So 1, 2, 3. And I'm going to start solving them. For the mean, what do we have? Well, expression under the square root supposed to be positive. Sorry. Which means that x minus 1 supposed to be greater or equal than 0, or x supposed to be greater or equal than 1 if we add 1 here and here. Denominator is going to make x plus 3 not equal to 0, or x not equal to minus 3. Now we're just going to draw a number line, and after that maybe write down the interval notation. So on my number line I'm going to have minus 3 and 1. Nothing is in scale. I'm just drawing the numbers to make it easier to write down the interval notation. So x greater than 1 is over here, right? Greater or equal than 1. We can allow x to be equal to 1 because square root of 0 is equal to 0. X equals to minus 3 is sitting over here, not in this interval. So actually, this number is not going to affect the interval of numerator. And because no numbers are allowed for numerator, that's going to be the only interval. So in interval notation, our final answer is going to be, well, I don't know where to write it on. I'm going to write it on over here right after. So x, sorry guys. Somehow I'm not very successful when I'm touching this whiteboard. X belongs to the interval square bracket because we are including 1 to infinity. So that's answer to our first question. That this point is not participating just because it does not belong to numerator. Simplify expression. Okay, for the first in numerator, I'm going to factor out 2. So it's going to be, that's a little bit strange that I have this arrow kind of looking like this. So I don't know why whenever I'm touching it, it's keeps moving. I'm trying not to touch it anymore. Okay, 2x plus 1 divided. Here in denominator, I'm going to use the formula a square minus b square. I'm going to write it on a square minus b square equals a minus b, a special multiplication formulas, a plus b, right? I was asking you to memorize them. So here my a is x, my b is 1, right? Because 1 square is 1. So I'm going to write on x minus 1 and x plus 1. Now I do see that I can cancel x plus 1 from numerator and denominator. And my final answer here is 2 over x minus 1. Okay. Move to the next question. Next question is to simplify expression here, which consists out of 2 fractions. Wow, to simplify this expression, I'll need to add these 2 fractions. And to add these 2 fractions, I must bring them to common denominator. But before I do this, I'll need to factor both denominators. In denominator of the first fraction, it's already factored. It's x plus 1 to the power of 2, which means that it's x plus 1 multiplied by x plus 1. But denominator of the second fraction is not factored, and I'm going to do this. I'm going to again use the very same formula I used over here and represent this denominator as x minus 1, x plus 1. Now I'm going to compare both denominators. What I see, the first denominator has x plus 1 2 times, and the second one has it only 1. So we are missing here for the first fraction x plus 1 in numerator and denominator. For the first one, we have x plus 1 2 times and no times x minus 1. That's what we are missing for the second fraction, x minus 1. Remember, whenever we multiply fraction by something, we're supposed to divide it by very same something because we don't want to change it. So I'm going to write down the first fraction, x minus 1, and denominator is x plus 1 squared x minus 1. For my second fraction, I have 2x plus 1, and because I'm just going to add one more x plus 1 here, I'm going to write down x plus 1 squared by x minus 1. Now, when I have same denominators, I can add numerators. And to make it a little bit easier for me to kind of do addition, I'm going to just open parentheses right away. So x multiplied by x is going to give me x squared, right? X multiplied by -1 is minus x. For the second fraction, we are going to have 2x multiplying 2 by x and 2 by 1. And 2 by 1 is going to just give me 2. Denominator is going to be just the same denominator, x minus 1, and x squared, x plus 1 squared. Now, in numerator, I can simplify it a little bit, right? I'm going to add these two expressions, minus x plus 2x, and I'm going to have x squared plus x, right? 2x minus x is just x plus 2. And I'm going to just copy denominator, which is not going to change, and I cannot simplify it any further, I guess. Well, at least maybe I still can simplify it a little bit. Let me think. No, I don't think that I can simplify. I was thinking to factor this numerator, but again, I did not teach you this first. And second, I don't think that we can factor it. Okay. So now we are going to move to complex fraction, compound fraction, and try to simplify it. Well, again, first step is to bring each numerator and denominator to like one fraction. So here for numerator, common denominator is x. So I'm going to multiply this x by one more x and have common denominator, which is equal to x. For this, for the denominator, I'm going to have common denominator y. So we have y squared plus x over y. Now I'm going to use the rule about flip fraction, right? X squared plus y over x multiplied by the fraction of denominator flipped y over x, oh, sorry, y squared plus x. Sorry, y squared plus x. Interestingly, my Microsoft Whiteboard just updated and now it doesn't work at all. Okay, now what I'm going to do, I'm just going to rewrite this expression. It's not always necessary to do, but you know, sometimes we can see better if we can simplify it or cannot simplify it. I'm going to copy parentheses first and then just a number. I don't think that we can simplify neither numerator or denominator here, so that's final answer. And the last question we have today is to rationalize denominator. Well, to rationalize denominator, I'm going to multiply by conjugate. Conjugate in this case is going to be square root of x plus square root of y. So it's square root of x plus square root of y divided over square root of x plus square root of y. Usually in numerator, you just copy 2x minus y and this square root of x plus square root of y. In denominator, we are going to use the formula a minus b, a plus b equals a squared minus b squared. In our case, a equals square root of x. So I'm going to have a square root of x squared. And y, square root of y is going to make our b, right? And that's going to be minus square root of y squared. Well, now we know that when we square something and extract the square root, we are going to get the very same expression. Okay, so I'm going to move a little bit lower so I don't make it too wide, my page. So I'm going to copy numerator 2x minus y, square root of x plus square root of y, and in denominator I'm going to write down x minus y. What I see in numerator and denominator both, I have expression x minus y. I'm going to cancel it. The only thing I have to remember that when I cancel this expression, actually the leftover is going to be 1. We're not going to divide by 0. And my final expression is a square root of x plus square root of y multiplied by 2. Okay, so I simplified everything and I solved all my self-work. Let me now kind of show it again. That was our self-work a little bit. Okay, so look at, once we can find the mean, simplify fractions by factoring, we can simplify fractions by adding them, we can simplify compound fractions and rationalize denominator, which is also simplifying. Now, guys, I want to consider several problems which are actually wrong problems. And I want you to think for a second what is wrong in each of these problems, okay? And then I'm going to explain too. It's not going to be like anything correct there. So let me kind of change my color. I want to kind of have something different. So it's going to point that something is wrong, okay? So let me scroll it up and write down what is wrong. And this is going to be self-exercise. And again, you can stop my video and try to kind of think what is wrong. So I'm going to give you several expressions, actually 1, 2, 3, 4, 5. And I'm going to use the rules wrongly. You can tell me what I'm doing wrong. I'm going to add two fractions and write down that it equals 1 over 2 plus 3. So think what is wrong here. Number 2, I'm going to open a square. A square plus b square equals a square plus b squares. So I'm doing wrong in this expression too. Number 3, I'm going to extract a root from 9 squared, from 3 squared, sorry, from 3 squared plus 2 squared. And I'm going to extract it like this, a square root of 3 plus square root of, so I'm going to write down that's 3 plus 2, also wrong. Number 4, I'm going to simplify another fractions, 2 plus 3 divided over 2, and I'm going to cancel over here 2 and get over here 3, also wrong. And the last one more fraction, 2 over 2 plus 3, and I'm going to again cancel 2 and have 1 over 3. Each of these problems has something wrong in them. Can you explain what? And again, stop my video, think 5 minutes, and then turn it back and listen to my explanation. Okay, so I'm going to change my color and do explanation, but I want you to try it on your own. Going back to blue. Okay, guys, I'm going to start explaining. Okay, you can look. So what we have over here, we are bringing to common denominator, but we are doing it wrong way, right? So common denominator here is what? Common denominator is 2 by 3. So we'll need to multiply this fraction by 3 and this by 2. So what is going to be actual answer here? Well, actual answer here is going to be 3 plus 2, and common denominator is 3 by 2 is 6. So actual answer here is 5 over 6. But wrong answer here is 1 over 5. Well, we do see that 1 over 5 is not answering the question, because if you take a half of a pizza and add 1/3 of a pizza, you're not going to get 1/5 of a pizza. So that's wrong. Okay, for distributing square, we know that when we have something in square, we actually multiply expression by itself, right? And we know that if we start doing this, if we really multiply this expression by itself, we are going to have a square plus ab plus b square and plus another ab. And our expression over here is missing actually this ab and this ab, which is going to be the reason why it's wrong. So this expression is wrong because it's missing actually 2 extra terms. Root extraction. Well, what we actually going to have over here? 3 squared is 9. 2 squared is 4, so we are going to have a square root of what? 13. Well, square root of 13 is, well, a little bit less than 4, a little bit less, about 4, but actually less than 4. What actually is 3 plus 2? 3 plus 2 is 5. We see obviously that this expression is wrong. We cannot extract square roots like this. The only way we can do a square root is distribute square root over the product. For example, if you have a product, you can kind of extract a square root of each factor, but you cannot extract a square root of the terms, no matter whether it's a sum or a difference, okay? Fractions, very typical mistake people are doing. Remember that actually this fraction is former sum of two fractions, 2 over 2 plus 3 over 2, right? If we add these two fractions, we're going to get this one. The 2 is common denominator. And of course, 2 over 2 is going to give us 1, and 3 over 2 is going to give us 1.5. So obviously, we are going to have not equal 1.5 is 2, 1.5, and 1 is 2, 2.5, right? So that's going to be not correct. Just 5 over 2, it's 2.5, not equal to 3. So we cannot cancel terms again. We can cancel factors. So if you have a multiplied by b divided over a, you can cancel a. And that's going to give you b. But you cannot cancel the sum, okay? Cross. Here, we're doing same mistake, but with denominator. We're trying to cancel 2, which is not correct because actually this fraction is equal to what? 2 over 5. And we know that 2 over 5 is not equal to 1 over 3 because 1 over 3, if you multiply it by 2, is going to be 2 over 6. 2 over 6 and 2 over 5. Obviously, 2 over 6 is less just because you divide the pizza into 6 parts and take 2 or into 5 parts and take 2. So they're not equal. Again, in this case, if you have a divided over a product, a and b, you can cancel a and have 1 over b. So we are using a good rule to a wrong expression. We cannot use a product or fraction or root rules to sums and differences. Well, I don't have any differences here, but you know, differences are going to work same way. Well, just kind of be aware of this typical mistakes and don't do them. But I know that eventually you will do them, but well, it will be good if you understand what is wrong. Okay, that's all for this lecture. Do your homework and we are going to finish and see you next class, next time.